Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy, variant Sudoku puzzle, and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called One More Time by Jonesy, and here are the rules. Hello, hello. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, which is a box. We have digits in a cage, sum to the small clue given in its top left corner, and digits do not repeat within a cage. So, for example, if this were, say, a 3, this would have to be a 6 because these two digits must add up to 9. And that's an example. You could have something like 2, 5, 7 here, and that would be valid. What you could not have, though, is something like 2... those were not good numbers to choose. 3, 8, and 3. Because 3, 8, and 3, while it adds up to 14, has a repeat within the cage, and that's not allowed. Also, within each 3 by 3 box, all digits belonging to the same cage segment, that is the part of the cage that is inside that box, must have the same parity. That is, they're either all odd or all even. A cage may change parity when it crosses a 3 by 3 box boundary, but this is not required. So, in this 3 by 3 box, these 3 cells must have the same parity. They're all odd or they're all even. Same with these 3 cells, right? But these 3 cells do not have to be the same as this cell. The same parity, shall I say, as this cell. So these could be different parities, and then this is the same parity. Or it could be different. Sorry, these are all the same parity. And this could be a different one or the same one as those cells. Anyways, have fun. And that's the last rule. We will try. Those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's learn how to Sudoku. Okay. We have multiple cages which only have one solution. That is, this 11 cage has to be 1, 2, 3, 5. The 16 cage must be 1, 2, 3, 4, and 6. This 16 cage must be 7 and 9. And this 34 cage must be 4, 6, 7, 8, 9. And those are the only sets of digits that add up to those specific sums. Right, because if you try to change a digit from like 4, 6, 7, 8, 9, if you try to increase 4 and decrease another digit, the problem is you'll have a duplicate. You'll have a repeat. If you try to decrease 6 and increase some other digit, you'll have a duplicate, right? 6, if you have 7, 8, or 9, 7 or 8 increasing, obviously... right, so decreasing 4... and that while increasing 6, 7, or 8 doesn't work because you'll have a duplicate. 6, 7, 8 goes to 7, 8, 9, but we already have 6, 7, 8, 9 there, right? Increasing 4 and decreasing 6 through 9 also has a problem, right? 7 through 9 will go through 6 through 8, which we already have in the cage. And increasing 4 and decreasing 6 will make them both 5, which will make that a duplicate. So... that's an example of these are just basically, if you've done a lot of killer cage Sudoku, which this is, you'll see that a lot. You'll see these, I guess not a lot, but you can start seeing these numbers a lot. Well, that means these are 4, 6, 7, 8, 9. They have to have numbers of different parity, and 3 of them are even. So therefore, these are the 3 evens, and these are the 2 odds here. So this must be 4, 6, 8, and this has to be 7, 9. Same with 1, 2, 3, 4, 6. We have 2, 4, and 6 must be even. And this is 1, 3 as a pair. So this is 2, 4, 6, 2, 4, 6, 2, 4, 6. This is definitely just 7, 9. So it doesn't matter which one they're in. This is 1, 2, 3, and 5. 1, 3, and 5 are the same parity, so they're all odd, which makes this an even and a 2. Okay. What else do we have? So where is 2 in this lower central box? It cannot be here. It has to be... these digits cannot be 4, 6, 8 because of the 4, 6, 8 triplet. And they can't be 2, so these are all odd digits. So this must be odd here to be in the same 3 by 3 box and the same cage segment. This must be even because we need an odd and an even to add up to a odd digit. So this is even. This is odd. This could be 2 evens or 2 odds. We're not sure. That means 2 has to be one of these 2 digits. We're not sure which. This is... Okay, so to add up a 22... Okay, Let's do this box. So we have 3 evens in this right central box. That means if we try to have 3 evens here, that would be 6 evens in the box, which is not allowed because we only have 4 even numbers. 4, 2, 4, 6, and 8. So this must be 3 odd digits. Since these are 3 odd digits, they will add up to an odd number. To add up to 13, which is an odd number, you need an odd and an even set. So this is odd, guaranteed, so this must be even here. Let's see. What are the possibilities? We have minimum 1, 3, 5. So that would add up with 4 to add up to 13. So this is either 4 or 2. And this could be 1, 3, 7. So we're guaranteed 1, 3 here. And we don't know if it's with 5 or 7. 1, 3, 7 adds up to 11, plus 2 adds up to 13. 1, 3, 5 adds up to... it cannot be 1, 5, 7 because that already adds up to 13. Cannot be 1, 3, 9 because that already adds up to 13. So this is 2 or 4. This could be 2 odds and 2 evens. We don't know here. Where are the 7 and 9 in this lower central box? They cannot be here. They can't be these 2. If we had both of them here, they would eliminate all possibilities for that cell. So one of them has to be here. Well, 9 can't be here because 9 by itself adds up to... adds up to 9. So you can't add up to 9 with another digit. So this must be 7, which makes this a 2. Now, to add up to 9 with 3 unique digits, you either have a 2 or it's 1, 3, 5. So this cannot be 2 in these cells. This can't be 2 here because of the 2 in the column. So this has to be 1, 3, and 5, which means all of these are odd. So this is 1, 3, and 5. That leaves, we have 5 odd digits in row 9. So that means the remaining digits must all be even. This is a 4, 6, 8 triplet, therefore this can't be 4, 6, or 8, it's 2. And this must be 4, 6, or 8. This must be 4, 6, or 8. In this lower central box, we have 4 even digits. So this cannot be even, it's odd. And we have now in row 7, 5 odd digits, which means the rest of the digits in the row are even. That means this lower left-hand box, we have 4 even, so this must be odd here. We don't know about this, though. So 9 has to be one of these cells, so it cannot be 9 here. This is 7, which makes this not 7, that's 9. These are 2 odd digits to add up to an even, that they add up to an even digit. So therefore, this must be even then also. These two are even. What else do we have? So 1 and 3 are guaranteed here. There must be a 1-3 pair in column 8. And they cannot be here because of the 1-3 pair in the box here and the 1-3 pair in the box here. And they can't be here because of the 1-3-5 triplet in the row here. So this must be all red. And this must be red then. And this has to be a 1-3 pair here. So because all 3 of these are red, they're all odd, which adds up to an odd digit. To add up to an odd digit here, you have to have odd and then even. So this is even. To add up to 28, you have to have a 9 in it, right? You have 4, 7, 8, 9, 5, 6, 8, 9. Is that 4, 7, 8, 9, and 5, 6, 8, 9? I think those are the only possibilities. Yes, those are the only possibilities. And you can't have a 7 because they have a 7 here in columns 3 and 4, which eliminates 7 as a possibility here. So this has to have a 9, which means the 9 is here, which means these are both odd. That means you can't have a 7. So this must be 5, 9, and 6, 8 here. So these are both even. We have in column 4, 5 odd digits. So this can't be odd. That's even. Since these are both even, that forms an even number. But to add up to an odd number, we also need an odd digit. So this is odd, which means we have in column 3, 5 odd digits. So this must be even. Okay. These are odd. This is odd. This must be even. So this adds up to 15. We have, these are 4. So 15 minus 4 is 11. So it could be 2, 9, no 3, 8 because we have a 3 in the cage. But it can't be 2, 9 because of the 2 in that box already. 2, 9, no 3, 8 could be 4, 7, or 6 and 5. And those are the possibilities. In column 6, we have a 4, 6, 8 triplet, which eliminates 4, 6, and 8 in the rest of the column. So this cannot be 4, 6, or 8, and it can't be 2 because of 2 in the box, so this must be an odd digit. Also, 8 has to be one of these 2 digits, so this cannot be 8 here. This can't be 2, so this must be an odd digit. To add up to 21, it could be 4, 8, and 9, but this can't be 9. So it cannot be 4, 8, and 9. It could be 5, 7, 9 if this is 5, 9, and that's 7. But it can't be 5 because of 1, 3, 5 triplet in the row. or it's 6, 7, 8. Therefore, it has to be 6, 7, 8. And this is 7. And we have 2 even digits here. That leaves 4 and 9 remaining in row 1. This can't be 9 because of the 5, 9 pair in the box. So this is 4. This is 9. So this is odd, and this must be even. This can no longer be 4, so it's 6 and 5, adding to 1 and 3 to add up to 15. Therefore, 6 cannot be here. This is a 4, 8 pair. 4, 8 eliminates 4 and 8 in the rest of the box, so this is 6. This has to be a 4, 6, 8 triplet here. How do you add up to these numbers? So 4 and 6 does not work here. Because if this is 4 and 6, this would have to be 7. And we already have a 7 in the column. So it could be 4, 8, or 6, 8. If it's 4, 8, this is 5. If it's 6, 8, this is 3. So either way, there's an 8 here, which means this cannot be 8. So it's 4 and 6. We have a 2, 4, 6 triplet in row 6, which eliminates 2, 4, and 6 in the rest of the row. And 2 is guaranteed to be one of these digits, so this cannot be 2. This cannot be 2 even numbers here, because in this box, then we'd have 5 even numbers when we can only have 4. So these must be 2 odd digits. Since these are 2 odd digits adding up, they add up to an even sum. To add up to an odd, this even sum must add up with an odd digit. So this is odd. And we have now 5 odd digits in column 7. So this is even. This is even. We have 4 even digits in column 8. So this must be odd and odd. And that leaves this as a 5. We have 5 odd digits in row 8. So this must be even. We have 5 odd digits in row 4, so these two must be even. Therefore, since this is even, these must be the same parity. And we know we need a 9 somewhere here, because 22 is either 5, 8, 9 or 6, 7, 9. So this is guaranteed to have a 9 and is odd. That eliminates 9 from being here. So this is 5. That's 9. So this has to be, cannot be 5, 9, and 8. It must be 7, 9, and 6. We also have in this upper left-hand box 5 odd digits. So therefore the remaining digits are even. We have 5 odd digits in row 3. So the remaining digits are even. We have in this upper central box, actually in the row 2, we have 4 even digits. That means the remaining digits are odd. Okay, in column 1, we have 4 even digits, so this cannot be even. This is odd. In column 5, we have 4 even digits, so these are odd. Okay. And I think that's all the information we really have. So now we just have to add these all together. This can't be 2 or 6, so that's 4 and 8. This can't be 2 or 6, so it's 4 and 8, which forces this to be 6 here. This can't be 6. Where is the 2 in row 4? It cannot be here or here, so it must be here. So this is 2, which means this can't be 2, so this is 4 because of the 6, 8 pair in the box. This is 2. This 6 eliminates 6 here, so it's 8 and 6 there. Remaining, this has to be an 8. 2 cannot be here. Where is the 2 in column 6 then? Can't be any of the odd digits, can't be here because of 2 in the box, so it has to be here, which makes this blue and 2. That leaves, we have 4 even digits in row 5, so this must be odd. We have 5 odd digits in this left central box, so this must be even, which forces 4 even digits in row 6, so this must be odd. Therefore, this is an 8. This must be 4, because this is an 8 because of the 2, 4, 6 triplet in the row. This is 4. That 4 eliminates 4 here, so this is 8, which means this cannot be 8 here. We have a 4, 6 pair in row 5, so this can't be 4, 6. This is 8. That means this can't be 8. That's 6, which makes this 8. Remaining even digits in row 3 are 2 and 4. We have a 2, 4 pair in column 9, which eliminates 2 and 4 in the rest of the column. This can't be 4. This can't be 2 or 4, but it also can't be 6, so this must be 8, which makes this 6. That leaves this as 2 or 4 here. This 2, 4, this 8 eliminates 8 here. So this is 4, which makes this 8, which makes this 4, which makes that 8. Okay, so this is 8, so therefore this must be 1 and 3 added together with it to add up to 12. This 1, 3 pair eliminates 1 and 3 in the rest of the column and the rest of the row, or box. So this cannot be 3, that's 5. This cannot be 1 or 3, so that's 5. So 5 cannot be here. 5 cannot be here. This can't be 5 because of the 5, 9 pair in the column. Whereas the 5 in row 9, it has to be here. So this is 5. Remaining digits here in this upper central box are 1 and 3. We have a 1, 3 pair in column in row 2, so this cannot be 1 or 3, can't be 5 or 9, this has to be 7. That eliminates 7 from being here, so this is 1, 3, and 5. 1, 3, 5 add up to 9, plus 4 adds up to 13, so it's 4, 2. 4 eliminates 4 here, so this is 2 and 4. This can't be 4 or 6, so that's 2. This can't be 2. These 5 and 8 adds up to 13. 17 minus 13 is 4. So this is 4. This is 6. 4 eliminates 4 here. So it's 6 and 4. This 5 eliminates 5 here. So this is 6, which means these two digits add up to 14 minus 6, which is 8. So it's either 1, 7 or 3, 5, but it cannot be 1, 7 because of the 7 in the box. So it's 3, 5. This can't be 5 because of the 5 in the column. So this is 3 and this is 5. This 3 eliminates 3 here, so it's 1 and 3. 3 eliminates 3 here, so it's 1 and 3. And that leaves this digit as a 9. Remaining digits in row 8 are 1 and 9. 1 can't be here because of the 1, 3 pair in the column. So this is 9, this is 1. 9 eliminates 9 here, so it's 7 and 9. This 1 eliminates 1 here, so it's 3 and 1. That leaves this digit as 7. We have a 1, 3 pair remaining in row 5, so this is 9. Okay, this is 7 or 9 here. So this is also 7 or 9 here. That eliminates 7 and 9 in the remaining digits in the remaining row. So therefore this cannot be 7 or 9. Where is the 7 then in the central box? Can't be here because of the 7, 9 pair here. Can't be here, so it must be here. So this is 7 with 1 or 3. And this must be 1, 3, or 5 here, and 1, 3, or 5 here. Can this ever be 7? This is at most 3 and 5 for these two digits. 3, 5, and 7 only add up to 15. So this cannot be 7. This is 9, which makes this 7. And this has to be 3 and 5 to add up to 17 with 9. So this is 3, 5, which means this can't be 3 or 5. It's 1, which makes that a 3, which makes that a 5. 3 eliminates 3 here, so it's 1 and 3. 3 eliminates 3 here, so it's 1 and 3. 3 eliminates 3 here, so it's 1 and 3. This can't be 3 or 5, so it's 1. This 9 eliminates 9 here, so it's 7 and 9. And that's the solution. Thanks for playing. How about this 6x6 easy as ABC loop puzzle? That's okay. We have done our easy puzzle here. Very cool, actually. Because of the rule constraints, we knew that we were probably going to be using a lot of evens and odd digits. There's quite a few puzzles that use this technique a lot. So this is a very useful technique to have, where you know that there have to be 5 odd digits and 4 even digits in every row, every column, and every designated 9-cell region. So once you get to the magical number of 4 evens in a row, column, or box, or 5 odds in a row, column, box, that will give you a lot of deductions from that. And this uses that constraint very beautifully. That was very cool. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.